So curve fitting with linear models means what we're going to do is we're going to take a set of data and we're going to fit that set of data with a line. And a line that we would call the best fit line. And researchers lots of times use statistics to do things, and they have to do and find what we call regression lines, which are basically lines that fit the data the best. A scatter plot can be helpful in understanding the form, the direction, and strength of a relationship between variables. And they use what's called a correlation to measure that strength. So if the numbers are all going up, if there was a positive slope, then we would say the correlation has a positive slope and a positive correlation. If there's a negative slope, then it has a negative correlation. And if they're all over the place, then basically there's no correlation at all. So if there's a strong linear relationship between variables, then we can go ahead and find the line of best fit. One thing you want to remember is that we really want to have the same number of points above and below the line of best fit that we're going to work with. And we're going to do this by hand first, and we'll talk about it by hand, but then I'm going to show you how to use your calculator to do it. So here we have Albany and Sydney are about the same distance from the equator. We're going to make a scatter plot with Albany's temperatures as the independent variable. What does that mean? Independent, where does that go? Is that X or Y? X. Okay. And so we're going to name the type of correlation and then sketch a line of best fit and find this equation. So when we find this equation, we're actually going to use our calculator to do that instead of doing that by hand. All right, so first of all, we need to plot the points. All right, so take out your piece of graph paper that you have. And once again, Albany is going to be on our independent, so that's going to go on the x-axis. And Sydney is going to go on the y-axis. So you might want to make a window that, let's see, what's the largest x value we need? Okay, 70. So we're probably going to go to maybe 75 or 80, right? Always going to go a little bit past. And how about y values? Okay, 66 is the largest, so you know the most you probably need to go to is 70. Okay, so you could go by tens if you want here to do this. Okay, so make your graph your scale. All right, and then we're going to plot these 12 points. So I went from 10 to 10 or 100 to 100, but you could just go up to 70 for both of them if you wanted, or 75, 80 on the X and 70 on the Y. All right, so we plot those points. We have the point 3165. That's going to be about here. And 3466. Close to there. See, I'm on October, so 5156 here, and 40, 60, and 3363. So once you have them all plotted, okay, then we need to name the type of correlation. So what kind of slope do these have? Okay, they have a negative slope, so that means there's going to be a negative correlation. Right? So as it gets warmer in Albany, it gets colder in Sydney. Then we want to sketch a line of best fit. And the one thing, like they said, is that when you draw a line of best fit, you want that line to go right through the middle of the point, so you have the same, basically the same number of points above and the same number of points below your line. Let's see here. Probably something close to that, right? Now, do we know how to find the equation for that line? Sure we do. Okay. We can find 2 points that are on that line, right? Okay. I could figure out what these points were exactly, and I could find the slope and the y-intercept and do them. It looks like the y-intercept is approximately 80, doesn't it? Okay. And then I could just estimate what the slope is, and I could get a line that would be pretty close to fitting them. But the one advantage we do have is we have a calculator will actually figure them out for us. Okay. So take out your calculator, and we're going to use our calculator to do this now. Okay. All right, and here's what we do. Okay. So the first thing you're going to do is we're going to put the data in our list. Does anybody know where your lists are on your calculator? Not second stat, but just stat. Okay. You can go stat and then edit. And everybody should be doing this right now because you're going to have to do this. This is one of the things you are going to need to do. Okay. Now, how many of you have data in those lists? Okay. So to get rid of the data, you go up to the list number, press clear, and enter, and they'll all go away. And whenever you start a new set of data, always clear your list. Okay? So now, put all of the numbers for Albany in list 1 and Sydney in list 2. And you can just type in the number and hit enter, and it'll go to the next one. And take your time, because if you make a mistake, it can be very costly sometimes as far as your accuracy. And when you're done, you might even want to go back and check them to make sure they're entered correctly. It's like I have a problem sometimes on the board here that it'll double click something. All right, so now we're going to make a scatter plot. Just similar to what you did on your paper then. So to make the scatter plot, and I have all this written down on the next slide, so if we To make a scatter plot, go to second y equals, where it says stat plots. All right, and go ahead and hit enter on the first one. And you should have the exact same thing that I have on mine. Okay. Except we're going to turn it on. We're going to hit enter there for on. Should be the very first one, should be highlighted here. That's a scatter plot. The next one is a plot over time, which means it'll do what? What's a plot over time do? Not necessarily decrease, but the points are connected, yep. Okay, plot over time, the points will be connected. We have a box plot, two different types of box plot. Histogram, then two different types of box plots. And then the last one is, I'm not sure what that one is actually. I haven't used that one in a long time. So then we show list 1 is where our x values are going to be. List 2 are y values. And then the mark it's going to make on our graph is going to be a little square. Okay? So now go to your y equals. And you'll notice that plot 1 is highlighted, right? Okay. Right. So when we're done doing scatter plots, then you can just go up there and you can hit enter there. And now it's not highlighted, so I just turned it off. Okay. So you can turn them on and off just by going to the plot on your y equals. So in the future, that's what you're going to want to do. Now, if you have anything in your list, clear them so they're gone. Get them out of there. We want those empty. Okay. So we went to stat edit to enter the data in our list. We turned our plot on, and now we're going to hit zoom, and then number 9, and what that does is it makes a window that fits our data. So if I hit zoom 9, it's going to make my scatter plot for me. Okay. So there's our, that was easy, wasn't it? Okay. All right, now we're going to find the line of best fit. Okay. So we've gone stat edit to enter the data, turn our plot on, and then zoom 9 to get a window that fits. So every time you put a new set of data in there, you're going to have to push zoom 9 again so that it makes a new window for your data. Because if I look at my window, look at the numbers. 27 to 74 basically for X, and 43 to 70 for Y. So it makes a window basically just big enough for our data. Okay. Now, to find our line, we're going to press stat again, and then we're going to calculate best fit line. So go over to calculate, and we're doing a line, right? So it's a linear model, and so we're going to do linear regression, which tells us our slope is A, our y-intercept is B. So instead of M, they're using A here, okay, because it's got to be alphabetical. So choose number 4, and then it'll look like this. Okay. All right, and then we're going to do one more thing. So our X list is list 1, Y list is list 2. We're not going to worry about the frequency, but go down to where it says store regression equation. Okay. This means store regression equation. Okay. And we're going to put that in Y1 so that when we hit graph again, it'll actually put the line on our graph. So to get to Y1, we're going to go to alpha and trace. And you can see Y1 there. Okay, and then hit enter. So Y1 shows up. So that was under alpha and trace. All right, and then go down to calculate and hit enter. Okay, and here's the equation for our line. It would be y equals negative 0.4638x, okay, because that's the value of A, and B is 80.08. Well, we figured our y-intercept was around 80, didn't we? Okay. We have negative correlation, so we're going to have a negative slope. Okay. Now push graph, and the line should go right through your data. Okay. All right. We'll talk about that in just a second. Okay. All right. So the line should go right through there. Does everybody do that? Okay. So whenever we want to find the best fit line, what we were doing, okay, that's the process we're going to go through to do that. Okay. All right. So let's talk about correlation for a second. All right. So correlation is The closer all the data points are to a line, the better the correlation. If the slope is positive, then the correlation is going to be closer to 1. If the slope is negative, then it'll be closer to -1. If we have a perfect fit, then it would be a +1 for a positive slope and -1 for a negative slope. Okay? So if you look at, we have all these different ones they show us here. Okay? So you've got 2 different negative slopes. These are all really close together. So this one, not too bad, but I can still see that the slope is negative. Okay? This one here, they're all over the place, so that would be like no correlation. These are pretty, these are, you know, I mean, I can see they go up to the right, but they're all over the place, so that would be, you know, maybe 0.6. And then the last one, oops, the last one down here, those pretty much gather around one specific line, so there's a positive correlation. Now, Caleb just asked, he said, okay, how about that R thing? Okay? So we figured that out. So everybody go back to your home screen. So second, quit. Okay? And then hit, it's clear now, right? Your home screen is? Okay. Hit enter, and this should show, and it should come back up. Okay. How many people have R, and, or let me ask this. How many people don't have R or R squared? Okay, a few of you. Good. All right. So press mode on your calculator. And then you're going to go down here to the second page on the mode. Right? And yours probably is highlighted at diagnostics off. Make sure the diagnostics are turned on. Okay. Right. And once they're turned on, if you hit enter again, then you should see R and R squared. Okay. All right, so we're going to, so one thing to remember is that slope and correlation are not the same. Okay? A negative slope means a negative correlation. Positive slope means positive correlation, but they're not the same thing because the correlation can never be bigger than 1 or less than -1, but slopes can definitely be bigger or smaller than that. Okay? All right, so we're going to go through this process again. All right, and then I have all of the stuff written down here, what we're doing. So, first thing we're going to do, go back to our list. All right, so we have anthropologists can use the femur or thigh bone to estimate the height of a human being. The table shows the results of a randomly selected sample. Okay, so, where do I start? Stat and edit. Okay. Clear your lists. Before you enter anything new in, always clear them, because if this new problem has less pieces of data than the other one, than the last one we did, you could have mistakes there, because if you forget to delete the ones at the end, you have a problem. All right, so we're putting our femur length in list 1 and the person's height then in list 2. And then make sure you go back through them to verify that you got the right one. And you can see I made a mistake there. Okay. Sometimes it's a little touchy. All right, so we did as number 1 says here, we put the data in our list under stat and then edit. And we have our plot turned on. So let's go back to our y equals here. All right, and our plot should be on. Now delete that or clear your y equals. So make sure that last equation we used is gone. Okay, it's out of there. All right. So then the next thing we're going to do is we're going to make a viewing window for our data. So we have to hit zoom 9 again. So we have a brand new window. And your should look like this. And then we're going to find the line of best fit. So we're going to go back to stat, then over to calc, and then we're looking for linear regression. So stat, calc, and then number 4, lin reg. And then we're going to, now this tells us, and this is when, if you had an TI-83, then you would have to go through this process here, but with our 84, it's a little bit easier. And so we want list 1, list 2, and then Y1. So remember, we're going to go down here to where it says store regression equation, go to alpha and trace, and there's your Y1. And then calculate. And then go ahead and graph it. So here's our graph. And so my equation then for this is going to be y equals, and we're going to use 2 decimal places, so 2.91x and plus 54.04 would be my y-intercept. So my slope is 2.91. My y-intercept is 54.04. So does anybody know what those numbers mean in terms of this problem? It is that, but what does that mean as far as the realistic situation we're talking about? Jesse? Okay, yep, all right, that's true. But what it means is that as the femur length changes by 1 centimeter, then their height is going to increase by 2.91 centimeters. Okay? So a 1 centimeter change in femur length is going to be a 2.91 centimeter change in actual height. And basically this y-intercept means that if they have a femur length of 0, okay, they would be 54 centimeters tall. Okay, is that realistic? No, but it does fit. It's a good fit for the data we have here, though. Okay, all right. Okay, so we did a scatter plot, found the correlation coefficient then in this case is R equals, and we'll use 2 decimal places is fine, 0.98. So is that a good fit or a bad fit? Okay, that's really good because it's very close to 1. All right, and we can see from our graph that the data is very close to that line. Okay, and that's a good thing. All right, and we wrote down our equation already. So all right, so here we have this other question. Let me bring this down. So it says a man's femur is 41 centimeters long. Predict his height. Okay. So there's 2 places to do that. Where am I going to find the most accurate answer at? Is this going to be the most accurate answer if I put x or 41 in here for x? No, the most accurate answer is going to be where? On your calculator, yep, on the table. So I can go to 2 different places, all right? And I'm going to show you the 2 places. Hit trace right now on your calculator. Press the trace key. All right? It says P1 up here, right? That means it's on the plots. Okay? So if I trace here, all it's going to give me is all the plot points. But I want to get to the line, so hit the up arrow or down arrow, and now it'll say y1. Then all you need to do is type in 41. So it says when x is 41, y is 173.5. So a 41 centimeter femur length would tell you that the person is 173.5 centimeters tall. And if you went to your table, you could go there also, find 41 in my x values, and I would still have 173.5 centimeters tall.